Hey guys, this is Coach Lowe, and we're going to talk a little contextual geometry here. Chapter 2, Section 1, Real Numbers and Number Lines. You will need the following vocabulary word and 3 postulates. You'll need to write those down and pop those in your notebook. Absolute value goes in your vocabulary section. It's the number of units a number is from 0 on the number line. So if I have absolute values represented with bars, if I have the absolute value of -5, what I'm asking you is how far from 0 is -5 on the number line. We know it's to the left. Negative numbers are to the left. I want to know how far this is. So distance is positive, so we go 5 units to the left. Absolute value of -5 is 5 because it's 5 units from 0. Postulate. When we talk about postulates, these are kind of like definitions. Postulates are assumed to be true without definition or without proof, actually. So without having to prove these, we just take these to be true in geometry. So postulate 2.1, number line postulate. Each real number corresponds to exactly 1 point on a number line. So if I ask you to plot 2 on the number line, you're going to plot a single point. There's not several different places to plot that. And then each spot or each point on the number line goes with exactly 1 real number. So it's a 1-to-1 here. Postulate 2.2, for any 2 points on a line and a given unit of measure, there's a unique positive real number called the measure of distance between the 2 points. Like we were talking about absolute value, we can find the difference of those two. We can skip count, but there is a distance, a specific distance between 2 points on the number line. Postulate 2.3, points on a line are paired with real numbers, and the measure of the distance between the 2 points is a positive difference of the corresponding numbers. Kind of goes along with 2.2. So when I look at the distance between those two numbers, I'm going to get a positive number. Distance is positive. Direction, like the negative, tells us what direction to go, but the distance between the two will be positive. All right, let's talk about the real number system before we get on a number line. So I'm going to draw a big box, and you will probably want to draw this with me. And we are going to start with the smallest set of numbers that there is. This is how you first learned about numbers. You learned to count, and they're called counting numbers. They're also called natural numbers. So these are numbers that start with 1, 2, 3, and then they just continue on forever. Just infinitely many numbers in here. These are called the natural numbers or the counting numbers, how you learned how to count. Natural numbers. All right, so the next box that we have, the only additional number in the natural numbers, to the natural numbers for this next box would be whole numbers. The whole numbers are the natural numbers and 0. That the only number that is not in the natural numbers would be 0. You didn't learn how to count with 0. You learned how to count starting with 1. So if you think about this, this is a box inside a box. So I have the whole number box that has just 0 in it, but inside the whole number box, I have the natural numbers, 1, 2, 3, and so on. So the whole numbers are the natural numbers plus 0. The next box that I have are called the integers. This is the integers. Integers are whole numbers and their opposites. So I have all the whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. And then I have the opposites of the natural numbers. Opposites would be like -1, -2, -3, and so on. No fractions, no decimals yet. So natural numbers are the counting numbers. Whole numbers, 0 in the counting numbers. Integers are 0 and the counting numbers, so 0, 1, 2, 3, 4, 5, and the opposites. Next, rational numbers. Rational numbers are any number that can be written as a fraction. If you can write a number as a fraction, it is a rational number. 5 is a rational number because you can write 5 over 1. Rational numbers are all of the numbers that are inside those boxes. Integers, whole numbers, natural numbers. We can write all of those as a fraction, even 0. 0 over anything except 0. So 0 over 5 can be written as a fraction that's still 0. But it also includes other numbers, decimals, like 2/3, repeating decimals, right? 2/3 repeats. It's 0.6 repeating, and we use a little bar over the number when it just repeats over and over and over again. 1/4. That's not a repeating decimal. It's a terminating decimal. So it stops. Terminating means stops. So 0.25 would be representation of 1/4. We also have weird things like 1/6, which is 1 and then a 6 that repeats. So if I write that out, we'll do an approximate. It would look like this, 1.6666. And on your calculator, it's going to round that last digit to 7, but it really just keeps going. All right, so there are a lot of decimals that repeat like that. You can have several digits that repeat. That means we would have 0.272727272727. The part that's underneath the bar is called the repetend. That's the part that repeats forever and ever and ever and ever. All right, so let's talk about this little box over here that's not contained in any of the other boxes. This box is called the irrational box. These are irrational numbers, like pi, square root of non-perfect squares, right? So that is our real number system. We will stay in the area of rational numbers. We will not talk about irrational numbers for a while. All right, so let's use the number line to find the measure. So we are going from L to X. From L to X. How many spaces would that be? We can count over, but we see that we're going from -5 to 5, so we can find the difference. All right, so to find the distance, you can take one coordinate and subtract the other coordinate from it, and then take the absolute value. That will give you the distance between 2 points, 2 coordinates. All right, so I have 5 and -5. So I'm going to do -5, that's L, minus X, which is 5. So -5 minus 5 can also be written as -5 plus -5, which is -10. But the absolute value of that is 10. That means if I count over from -5 all the way over here to 5, it would be 10 spaces. So you can count that if you want to. We'll just keep rolling with this. All right. Pause the video and try the rest of the problems. Okay, now that we're back, let's go over these. Finding the distance from 1 to 5. So the absolute value of 1 minus 5 is -4, which is 4 units. By the way, you can flip those around and do 5 minus 1, totally fine. Still get the correct answer there. All right, now let's go from Z to T. At any time you need to stop the video, please do so. All right, from Z to T, -2 minus 1 is -3, because it's -2 plus -1. Same sign, just add them and pop that sign on it. Absolute value of -3 is 3. So I have 3 units away. Notice I have half units on here as well, but we're just counting the whole units. 3 units away. All right, let me get some of this off of here, because now we're going from L to Z. So looking at those numbers, L is -5, Z is -2. So -5 minus a -2. Now I have minus a negative. 2 negatives together like that. We can say plus a positive. So -5 plus 2. Now I have opposite signs that I'm putting together, so I subtract those numbers. And the absolute value of -3 is 3. All right, we have 4 more. If you need to pause the video and go back and try those, then do it. Or we can work one and you can pause whenever. All right, so now we're going from S to T. All right, now check this out. As we move this direction, I notice there is 1 tick mark, which means this is a half. So I have 0.51, 1.52, 2.53, and so on. So S is 0.5, and I'm going to subtract 1 from that. So it's like 50 cents minus $1, which would be -50 cents. And the distance would be positive. I'm going to put a 0 in front. So 0.5 or 5/10 away. All right, now we're going from L to Q. L to Q. Remember, we're going this direction as we count. These are negative numbers. So I have from 0, I have -1/2, -1, -1.5, -1.5, -1.5. All right, so I want the distance from L to Q. All right, minus a negative, so I have -5 minus a -1.5. Changing the negatives to a positive, I have -5 plus 1.5. Opposite signs mean I will subtract. All right, so I'm going to come over here to the left side and do that. I'm going to put 5.0 minus 1.5, or you can definitely use a calculator, although we don't need one. That would be 3.5, and it's negative, but absolute value makes that guy positive. So 3.5 units away. We can count that over, 1, 2, 3, and then a half to get there. All right, from B to Y, is a half a unit also. So 0.5. And if you want to subtract that, you can definitely do it. 2.5 minus 3, or 3 minus 2.5, and you'll get negative 0.5 the way I set it up, which gives you the absolute value of a negative half is a half. All right, last one, A to X. Negative 3.5. Remember, we're counting this direction because we're going to the left and the numbers are negative. Negative 3.5 minus 5. Negative 3.5 minus 5. Numbers are now the same sign if you want to change that to plus a negative. So I'm going to add 5 and 3.5, which would be 8.5, and it's negative, but I shall take the absolute value, and that makes that positive. All right. That is really all that I have for you. I'm going to ask you a few things in class on Monday, like writing an irrational number between two numbers and writing some rational numbers. And we will definitely talk about that as we look at the number line, talk about writing numbers between those whole numbers and between those integers. So high five me when you see me. That way I know you've watched the video, and I will see you guys soon. This is Coach Lowe, and I'm out.